Let's see about digestion, absorption, transport, and storage of iodine. Dietary iodine is either bound to amino acids or found free, primarily in the form of iodate or iodide. During digestion, organic bound iodine may be freed. Iodate is usually reduced to iodide by glutathione. Iodide ion is absorbed efficiently than the other forms. Iodine enters the brush border of enterocyte as iodide through passive diffusion and passes to the blood. Iodide is absorbed rapidly and completely throughout the GI tract, including the stomach. Thus, very little iodide appears in the fecus. The thyroid hormones, thyroxine and triiodothyronine, are also absorbed unchanged with a bioavailability of 75%. The thyroid gland traps iodide most aggressively by sodium dependent or active transport system against an iodide gradient that is often 40 to 50 times the plasma concentration. The thyroid gland contains 70 to 80% of the total body iodide and takes about 150 microgram of iodide per day. Following absorption, free iodide appears in the blood. Iodide is distributed throughout the extracellular fluid from which it is capable of permeating all tissues. Iodine is most highly stored in thyroid gland with lesser amounts found in ovaries, placenta, skin, salivary, gastric and mammary glands. Next we will see synthesis of thyroid hormone. They are synthesized in thyroid gland. In thyroid gland, we have follicles, parafollicular cells or C cells, and these are blood vessels. This is basic histology of thyroid gland. Follicle has color at the center, surrounded by follicular cells. Thyroxine and triiodothyronine are synthesized by follicle. C cell synthesizes calcitonin. Thyroxine and triiodothyronine are structurally and functionally similar, and thyroid hormones is usually used to refer to these two hormones only. Calcitonin is different. It is involved in calcium and phosphate homeostasis. So it is usually discussed with parathyroid hormone. Let's go into the function. First step in thyroid hormone synthesis is active uptake of iodide. It is carried out by sodium iodide importer. This uptake is against electrochemical gradient, and energy for this transport is obtained from downhill influx of sodium. From cell, iodide is transported into the colloid by transporters called pendrin. Now parallel to this iodide trapping, cell synthesizing thyroglobulin. It is a glycoprotein. These are tyrosine residue of thyroglobulin. As it is synthesized, it is stored in secretory vesicles. The vesicles also has enzyme thyroperoxidase on the intravascular surface. Now, the vesicle fuses with the apical membrane and releases thyroglobulin into the colloid. This also brings thyroperoxidase on the cell membrane facing the colloid. Here it carries out several reactions. First, it catalyzes oxidation of iodide into iodine. This iodine then binds with tyrosine. This binding is also catalyzed by thyroperoxidase. Likewise, so many other tyrosine residues are also iodinated. This forms monoiodotyrosine, that is tyrosine with one iodine, and diiodotyrosine, that is tyrosine with two iodines. And these are more mono and diiodotyrosines. Now enzyme catalyzes coupling of some of such iodinated tyrosines. If one mono and one diiodotyrosines combines, it forms triiodothyronine. Here there are two possibilities. One is we can have one iodine on outer ring and two iodines on the inner ring. This is active triiodothyronine or T3. And second is two iodine on outer ring and one iodine on the inner ring. This is called reverse triiodothyronine or RT3. It has no biological activity. So this T3 is more important here. Now if two diiodotyrosine combines, it forms tetraiodothyronine or T4. Quantitatively, much more T4 is synthesized than T3. The hormones thus synthesized are stored in colloid as part of thyroglobulin. Then when there is time for release the thyroglobulin, it is taken up by the all by process of endocytosis. Then lysosome fuses with this vesicle and releases its enzyme. The enzyme hydrolyzes the thyroglobulin to form T3, T4, monoiodotyrosine and diiodotyrosine. T3 and T4 are released into the blood as they are lipid soluble. They passes through the membrane and no transporter is required here. Mono and diiodotyrosines are deiodinated and iodine thus released is reutilized. So this is the entire process. So far we have seen the function of iodine, how it is used to synthesize the thyroid hormones. The thyroid gland can trap about 60 mg of iodide daily. Now let's see how it is transported in the blood. After releasing T4 and T3 into the blood, these are associated with transport proteins and are distributed to target cells in peripheral tissues. Three transport proteins bind and transport T4 and T3 in the blood. Thyroxine binding globulin found in the plasma has the smallest capacity but the greatest affinity for T4 and T3. Here, T4 attaches more than T3. Albumin and transthyretin also transport the thyroid hormones. The unbounded T4 and T3 binds to the cell receptor. Here, T3 gets attached more than T4. The plasma concentration of T4 is nearly 50 times that of T3, but T3 is many more times more potent on an equal molar basis. Several tissues can deiodinate T4 to generate T3 and RT3. Most T3 in the blood has been synthesized in the liver from T4. A selenium-dependent 5-deiodinase generates T3 and a 5-deiodinase generates RT3. Conversion of T4 to T3 is impaired with the selenium deficiency. So this is the function and transport of iodine.